Thanks a lot for joining the United Soybean Board and industry leaders Goodyear Tire and Rubber and Ford Motor Company for today's webinar. We'll hear from the company representatives who will share their insights and opportunities gathered through their extensive work with soy as a sustainable bio-based alternative in tires and auto. And we also hope the college students on the webinar will be excited to hear from our speakers about internships and other opportunities within these companies. Before we get started, I'd like to recognize three organizations that have been great partners to USB and for their support of this webinar and sharing this opportunity with their networks. First, I'd like to thank the American Oil Chemists Society, then the American Society of Agricultural and Biological Engineers, and last but not least, the National Council for Science and the Environment. Anytime we have a webinar like this, I like to give a little bit of information and background on who the United Soybean Board is. You can see there a slide that shows where most of the soybeans are grown within the United States. United Soybean Board and the Soybean Checkoff was established in 1991 by an act of Congress. It has a 73-member board that represent all of these states that are pictured here, and all of our board members are nominated by the state that they come from, and then they're selected and appointed by the Secretary of Agriculture in Washington. The United Soybean Board, our key strategy is to create and enhance partnerships that increase the value and preference for U.S. soy. We've done that quite extensively with two of the speakers that you'll hear from today. We've had great working relationships with these two companies and many others around the United States. The soybean checkoff, for those that don't know, anytime a farmer sells a bushel of soybeans, 0.5% of that total sale is collected within the state that it's sold. 50% of those dollars are retained within that state, and 50% come to the national organization. Those dollars can be used for anything except infrastructure and building buildings and things like that, and lobbying. So anything with market development, research on how to grow more and better soybeans, industrial uses, international market development, things like that. In the industrial research area for USB, we concentrate in the following areas: biodiesel, plastics, coatings, inks and solvents, adhesives, fiber, paper coatings, and then anything emerging industrial uses. We're always looking for new thoughts and new ideas on how we may spend checkoff dollars and bring new products to the marketplace in the future. We've always looked at our organization as having a portfolio. We're looking at a lot of different, not spending all our money in on one thing or one item, looking at doing a lot of different things, and we've been successful in many. We'd also like to invite any college students that haven't joined the Collegiate Biobased Network to do so. There's no charge. It's sponsored by the United Soybean Board. It works to connect college students with bio-based industry, with bio-based interest to industry leaders. Use it for information sharing on bio-based research, federal and state programs, and anything that comes up that we think that you may be interested in. We try to get that information out. And it's also a good opportunity for networking and mentoring. You can see the website on the bottom of the page there that if you're interested, go check it out and sign up. Now it's my honor to introduce our two speakers for today. First, Robert Woloszynek is Ph.D. and Chief Engineer, Polymer Science and Technology, Goodyear Tire and Rubber Company. Goodyear's cooperation with USB yielded a first for the tire industry. Following extensive experiments, lab testing, road testing, Goodyear last fall introduced soy-based technology in its Assurance WeatherReady tires. It's a broad line of tires that covers 77% of the cars, SUVs, crossovers, pickups, and minivans. Our second speaker this afternoon is Janice Tardiff, Elastomer Materials Technical Expert, Design and Final Assembly Department with Ford Research and Advanced Engineering at Ford Motor Company. All Ford vehicles produced in North America contain soy-based polyurethane foams in seat cushions and back, and USB funding supported joint research with Ford that led to the commercialization of that foam. Ford continues to look for additional ways to incorporate the use of soy and other renewable materials in its vehicles, and one day hopes to completely eliminate the use of petroleum-based parts. After these presentations and throughout the presentations, we ask you to submit questions, and at the end of both presentations, we will open the floor and ask the questions that you've submitted. And prior to getting started with the first presentation, I'd like to have everyone join and complete this survey question, which is, which of the following is the primary reason you joined today's webinar? Number one was environmental health benefits of products, energy security or reduction in petroleum. The webinar is relevant to my research, interest in learning about bio-based products for our fleets, or interest in exciting career opportunities. So if you vote, in just a moment, we'll have show the results. Okay, it looks like most everybody has voted, and I see that the largest vote getter was interest in learning about bio-based products for fleets, followed by webinars relevant to my research and environmental and health benefits of soy products. So all very good reasons, and we're, like I said, we're very glad that you're on with us today. What I'd like to do now is turn the presentation over to Bob, and look forward to hearing your comments about Goodyear and their work with soy.
Okay, thank you, Mike. Good afternoon, everyone. Today I want to give a brief overview on some of the technical background regarding our work using soybean oil as a replacement for petroleum-based oils in oil extended polymers and tire tread compounds. The big key to the success of soybean oil getting into one of our premium consumer replacement products is the fact that this material brought a performance benefit and provided performance that we were not able to achieve without the use of the material. Very quickly, I'll just say that we are constantly screening new exciting materials and innovative technologies, and sustainability is important, but for a material to make it into one of our premium products, it really needs to deliver true performance. So that's really going to be the focus of my talk today, is to sort of give you an overview of technology development for tire performance. The first thing I'm going to do is give a very brief overview of Goodyear's polymer technology, and then some of the polymers that we use in our tires, specifically in tread compounds for high performance tire applications, and how the properties of these polymers impact both processing and performance. I'll talk about the benefits of soybean oil, some of the unique properties that soybean oil has, how we were able to leverage them throughout the development of a new polymer product and the subsequent introduction into some new tire products from Goodyear. So very quickly, as Mike mentioned, I'm Chief Engineer of the Polymer Science and Technology. That's sort of a way to say this is the and rubber part of the Goodyear Tire and Rubber Company. So we have R&D facilities in Akron, Ohio, and we support some of our polymer plants that we have here in the United States. We have a solution polymer plant in Beaumont, Texas, and then we also have an emulsion facility in Houston, Texas. And here we are able to develop, produce polymers that support our tire plants around the world. So focusing specifically on styrene butadiene rubbers, these polymers are very prevalent in our tread compounds. We have a portfolio of products to serve the global tire market. Every region, every application has different needs, different performance requirements, and we're able to develop technology and tailor our materials to meet a full range of tire properties. And the use of specialty polymers is ever expanding in the consumer as well as the commercial realm. One thing that really provides benefit in ultimate properties is high molecular weights of various polymers, and this is where the use of oils and oil extension allows us to be able to process these high performance materials. So it's all about driving technology. What are some of the current drivers for tire technology? Wet performance, increased fuel efficiency. There's tire labeling in a couple of regions. It's prevalent in Europe, where the tires that you buy have a label. This gets a B for wet traction and a B for rolling resistance, and you know the consumer is able to make decisions based on how these tires are rated. In North America especially, we really value treadwear. So there's always a balance of performance that we're trying to achieve. Certain tire applications require more of a focus on one specific technology, and you can see on this list we also have sustainability there. Sustainability is not lost on us. It is very important. It is something that we pride ourselves in, but you can see the overall focus that we have on tire performance for our customers. This slide is a brief summary of what we call the performance triangle. Pick 3 random tire performance attributes here and sort of made a triangle. And the one thing about tire compounding and tire design is there are performance trade-offs. There's not a tire out there that gives you everything, that gives you perfect wet performance with perfect snow performance, that has a treadwear warranty of 100,000 miles. Those don't exist. So there's trade-offs, there's things we could do around our compounding and our selection of materials. And one thing that we really look to do here in R&D is to minimize the trade-offs and expand the triangle to where we're able to improve multiple performance parameters simultaneously. And these high performance polymers that we develop are a big part of that. The only issue with these high performance polymers is whether they're high molecular weight polymers, whether they're functionalized, is that they are often more difficult to process. So there's always that balancing act as well. So that's where oil comes in. So again, as I said, high molecular weight polymers, high filler loadings to increase wet traction. All these things we use to improve our tire properties They all come at a cost of poor processing. So what do? We use oil. Oil addition lowers the viscosity, whether it's the viscosity of the polymer during finishing or added to the compound as an ingredient. There's really two addition strategies that I'll refer to here. So when we add oil just as an ingredient to a compound mix where we're adding filler and different rubbers and other additives, we'll add oil directly to the mixer. That is considered, we consider that free oil. And then we will add oil to either polymer cement in the case of solution polymers, or to latex in the case of emulsion polymers prior to finishing. So basically for solution polymers, it's where the solvent is removed, and that is called extender oil. So why soybean oil? Why are we looking at this? Why have we continued to develop around this material for the past couple of years? It's appealing because it's domestic, abundant, and renewable. That at least got us looking at it for sure. The sustainability factor was big. And in our early development efforts, we started looking to see if soybean oil possessed the key attributes required of extender oil. Thermal stability is obviously a big one. If it didn't have adequate thermal stability, it wasn't going to go anywhere. And then the physical and chemical compatibility with the rubbers that we use in our tire compounds. The green movement is a growing industry trend, but in the end, it was the unique properties of soybean oil that we were able to leverage and provide a nice balance of performance and processing. This type of innovation it's consistent with Goodyear's commitment to being an innovation leader within the industry, which keeps us competitively advantaged and hopefully profitable through various economic cycles. Here is a brief overview of the types of oils that are used. The aromatic oils have been phased out over time. So the majority of our oils are these medium extracted solvate, heavy naphthenic type oils. And you could see just hydrocarbon oils versus soybean oil, which is obviously a triglyceride, domestic renewable resource, and the soybean oil that we are working with currently is just conventional soybean oil. Some of our early work was focused on looking at the compatibility of soybean oil with our tire polymers, specifically styrene butadiene rubbers, or SBRs. And the one thing that we realized right away was that it had better miscibility. Soybean oil was more miscible with SSBR than the current oil we were using. And this is big for us, whether it's as a polymer extender or if it's as a free oil addition, is that we needed less soybean oil to provide the equivalent viscosity reduction, polymer extension, however you want to put it. But basically, we got to use less soybean oil on a part level than petroleum-based oil. That's big. It gives us a lot more flexibility in the design of our polymers and in the formulation of our compound recipes. What else is unique about soybean oil? Well, since it's a vegetable oil, it's triglyceride. The glass transition temperature is far lower than the traditional petroleum-based oils. So the glass transition temperature is the temperature at which a material goes from amorphous to glassy, from rubbery to glassy. So obviously the lower the glass transition temperature, the softer the rubber will stay at these very low temperatures. And here's a quick comparison of an identical polymer microstructure. We took this commercial polymer cement and added oil to the cement, and you can see here in this TG inflection column a significant shift in the glass transition temperature of the extended polymer when petroleum-based oil was substituted with soybean oil. So why is that important? Well, what we could do is we can alter the polymer microstructure to accommodate soybean oil. So what does that mean? We have a current inline commercialized styrene butadiene rubber that is extended with petroleum-based oil. It has a glass transition temperature of -38, and that's all important in our compound formulations, you know, and how we put everything together. But glass transition temperature is very important because that really gives us our wet rolling resistance and our wet winter balances in our tread compounds. So this, starting here at the bottom right, you see our control polymer, a direct oil replacement, really shifts the TG, and then we did some polymer development work around it to get the same composite TG, only extended with soybean oil. So what does that do? It basically allowed us to combine a high TG polymer that would be good for possibly a wet application, but given the extremely low TG of soybean oil, we sort of are able to balance our properties a little bit better and make a unique material. In August of 2014, we achieved technical release of this material, basically showing equivalent performance to the inline, but with noticeable improvements in processing, and that's due to the better miscibility of soybean oil with the rubber. We started looking at that material in new product developments. It was an iterative process. A large team was involved with it, cross-functional efforts. But in the end, soybean oil, the combination of the low TG soybean oil with the high TG rubbers, you know, basically allowed us to alleviate the typical trade-offs you get for wet performance and winter performance. The reason why high-performance summer tires perform so well in the summer on your sports cars and things like that are that they're very soft compounds. But those soft compounds have a very high glass transition temperature, so that in the wintertime when it gets cold, that rubber gets hard and brittle. It's not as pliable, and you don't get your winter traction. Here we were able to achieve both simultaneously, and we were able to use our released soybean oil extended polymer in the Assurance WeatherReady tire. So released last year, the Assurance WeatherReady tire contains a soy-based compound where 100% of the petroleum oil was replaced with soybean oil in the tread compound. And that leads to a total petroleum oil content reduction of about 60% compared with a predecessor tire. Our soybean oil initiative actually won Tire Technology International's Environmental Achievement of the Year. This was an award that we received in February for our work with soybean oil and the development of the first consumer passenger product containing soybean oil. About a month ago at our customer conference, we introduced the Eagle Enforcer all-weather tire. This is a police tire for the pursuit vehicles, and this should be released later this year. but this is another tire where we're looking for premium all-weather traction, for our officers of the law. It's vital, all-season performance, and once again, soybean oil was chosen as an enabling technology. So, in conclusion, we've commercialized 2 new tire products in the past year or so containing soybean oil. The unique properties of soybean oil were leveraged to meet our performance goals, and there are other ways that we're currently looking to leverage soybean oil as well. It's not just for the wet winter balance. That's how we did it the first time, but so far we're very pleased with the performance of the WeatherReady tire, and we're continuing our efforts to expand this technology into additional product lines. And we are in the process of trying to secure some intellectual property for some new ideas this year. We got a lot of new ideas. There's a lot of work being done right now to really carve out our IP space. For any college students that on the line, internship opportunities are posted. We invite you to go to our website, campus.goodyear.com, and take a look at some of our internship opportunities along with some other really helpful career information. And finally, I sincerely want to thank, on behalf of Goodyear, the United Soybean Board for helping support these research activities since 2011. It's been a great partnership with them, and I'm just thrilled with how everything has gone the last few years being involved with the USB.
Thank you, Bob. I really appreciate that presentation. Now I'd like to reintroduce Janice Tardiff with Ford, and look forward to your presentation. Take it away, Janice.
Great. Thank you very much. So I'm going to talk about sustainability at Ford and talk about the renewable and recycled materials that we use in automotive components. So at Ford, we have a very strong sustainability policy, and it's being driven by from the top of our organization, from Bill Ford Jr. himself. And really, there's 3 primary pillars to this sustainable policy. When we look at the environmental and social aspects, we really want to, whenever possible, or at least be aware and make sure we are minimizing our impact in how we obtain materials for our vehicles, how we produce our vehicles, and in use, how those vehicles impact the environment and social societies in where they're used. But part of that also needs to be the economic space, where we need to also ensure that we are providing value to the customer and affordable vehicles. So we're constantly trying to make sure that we are creating the right blend of materials and for use in our vehicles to meet these 3 pillars. As far as the materials that we actually use on our vehicles, we have up to 40,000 parts on a vehicle. It's a pretty large number. I'm always surprised when I see that myself. Approximately 1,000 different materials and 10,000 different chemical substances. So there's plenty of work to do in the materials area here at Ford. With that in mind, that on how many different materials that we're using, we always are looking for ways to increase our use of recycled materials. We want to develop plant-based renewable materials and incorporate those materials into our parts and onto the vehicle. We certainly want to eliminate substances of concern, heavy metals, etc. We want to address the end-of-life impact through improved recyclability of as many components on the vehicle as possible, and then work with environmentally and socially friendly suppliers. So it's not just the vehicle itself. We look at the full supply stream and the manufacturing stream, going back all the way to things like mining and the production of the raw materials, how we're looking at the materials and the fuels, how we fabricate it, how do we actually manufacture, and how can we minimize our impact there. The vehicle assembly, that includes vehicle assembly as well as the parts, the components. How the vehicles are used and maintained, things like oil changes and minimizing the amount of waste that is used or produced in that process. And then end of life with recyclability. We have made huge strides in the water usage at our assembly plants, as well as reduction in waste streams. We try as often as possible in areas such as the stamping plants to recycle materials that are called offal, that a stamped part has excess material. We try to recycle all of that kind of material. So we're always on the lookout for ways that we can improve our environmental footprint. When we look at, we've had some success with incorporation of sustainable materials into our vehicles. We have used post-consumer recycled waste, carpeting, water bottles, etc., into some of our parts components. I mentioned the aluminum scrap that we recycle back into more sheet metal. And so the diagram there shows you all of the different areas where we are using either recyclable or renewable materials. And oftentimes, especially with renewable materials, we find that those are also lighter weight, and that whenever we go with a lighter weight component, that helps us with fuel economy and also then improves the sustainability of our vehicles, or sustainable performance of our vehicles. So on average, Ford is currently using, depending upon the vehicle, 20 to 40 pounds of renewable materials. And in some of those locations where we would use those materials, where we've had great success, has been the soybean oil-based foams, seals and gaskets. We've used castor oil-based PA11 and foams, and natural fiber reinforced plastics. So as we try to incorporate some of these very new materials, there's a lot of challenges in terms of performance. It always has to meet the performance expected of the customer and durability. So we need to look at all of our engineering specifications, right, to make sure it's performing properly when we incorporate these new materials. Appearance is one. Odor is another big one, particularly in the interior cabin, and any volatile compounds that might be off-gassed. The performance strength. There are certain key areas where we have to have good impact, or the part needs to be very stiff, and we can't sacrifice any performance in those regions. We make vehicles all over the world, so it has to be globally available, or find some various alternatives that are globally available. Moisture sensitivity is another. We don't want, sometimes sustainable materials we see an uptake in moisture, so we have to be careful on where we place those materials. Chemical compatibility. Many of our parts on our vehicles are exposed to fuels or other chemicals, even people's, the oils on fingers, etc. So there has to be some chemical compatibility depending upon where the part is being used. We need to make sure as well that it's economically viable and doesn't add to the cost of the vehicle. And then some of the challenges that we have for recycled materials is really the fact that currently there's not a great market for many of these recyclates, and that's part of what we're trying to do, is trying to find ways to incorporate some of these recycled materials back into our parts in very specific locations and create a demand for those particular materials. There's also the economics. There's some raw materials that are so low cost, particularly with lower gas prices or petroleum oil prices currently, that it's really hard to replace those materials with a sustainable recycled part. We expect that will probably change in the future. So we're doing all of our research right now to be ready to incorporate those materials when the economics make that a valuable opportunity for us. So when we look at the sustainable materials portfolio, I'm here in the research lab, and we are looking at a variety of different possibilities. Bio-based foams, we've had great success with the support of the United Soybean Board on our bio-based foams. We've also been looking at natural fiber composites. So we're looking at various cellulosic-based materials, and really sometimes, as I mentioned previously, where we might use wheat straw, let's say in North America, maybe bamboo makes more sense in Southeast Asia. So we really look at where these materials are available and focus on locally sourced or somewhat locally sourced materials. Recycled materials, we've looked at jeans, bottles, money even. It's amazing how much extra money is shredded, and that's actually a really nice cellulosic type material that can be put back into particularly plastics. Renewable elastomers, we've been looking at dandelion, rubber, Wyuli rubber, and soybean oil, as well as many others that I'll mention in a moment. And then the bio-based resins, looking at different fermentation, CO2 capture for fermentation, sugarcane, corn, dandelion. And so let's talk a little bit about Ford Motor Company's use of soybean oil. We have a very long legacy with soy. So Henry Ford was our founder of Ford Motor Company. He really wanted to make that connection between farmers and manufacturing, and so he worked very closely with the local farmers here in Michigan, and really wanted to promote the use of soy. And so these pictures kind of represent some of the different products that he had produced. The first picture on the left is a deck lid that was made, it was a composite made with soybeans, and he's got a sledgehammer in his hand, and it actually performed incredibly well, and the sledgehammer just bounced right off of that particular part. So it was very strong, and really making the point that you can use this kind of material in manufacturing. The second picture is Henry Ford. He's actually wearing a soybean suit, and so he really experimented quite a bit in a variety with a variety of different products and how to use soybeans, and was a big promoter of this. And then what materials have we used here at Ford, and what successes have we had? As Mike mentioned at the beginning of this webinar, the soy-based foam has been the biggest success that we've had with soybean, and we anticipate seeing more of that. First OEM, when I say original equipment manufacturer is OEM, so we're led the way in the production of seat foams, and so all of our North American production, the seat foams are made with soybean oil, and 75% of our headrests as well. Then we've used soy foam and recycled tires and gaskets for 14 different vehicle platforms. And so this is diverted, more than 5 million pounds of petroleum out of our vehicle production, which we take great pride in. We want to make sure we continue to do that kind of work, and reducing CO2 emissions as well. Another really important fact that we need, and that's why we want to continue to promote these kinds of products. We've also looked at or incorporated wheat straw into some bins on the Ford Flex, canna fiber into bolsters on the Ford Escape, and cellulose composite on our Lincoln MKX console lid. Most recently, we've had our industry first use of soybean oil in a natural rubber part. It's a tip insert on the F-150, otherwise known as a slat pad. And I wanted to kind of walk through how we got to that point and utilizing this material in that particular part. Elastomers, just so you know, some people think no elastomers, but elastomers, rubber, we use those two words oftentimes interchangeably. And so I wanted to point out all of the different places where elastomers are used. And there's a variety of different types of elastomeric material. There's natural rubber, there's EPDM rubber, styrene butadiene rubber, which Bob mentioned. So there's butadiene rubber, so there's many different types of rubber, and they're really, you know, they're all over the vehicle. Oftentimes, you know, it's better when people don't notice it, because that means the rubber's probably performing really well, because they're usually in hidden locations that you don't notice. They're in seals and gaskets, engine mounts, suspension bushings, hoses and tubing, splash shields, obviously tires. That's the glamour side of use of elastomers, door seals and that sort of thing. So the average vehicle has about 9 kilograms of EPDM rubber and about 3 kilograms of natural rubber, just in the part. That's all non-tire application. This gives you a better picture of some of these natural rubber parts. And so you can see it's usually, this rubber is oftentimes used when you have two metal components and you put the rubber in between those two metal components so that it provides a smoother ride of the vehicle. And so there's a lot of dynamic stress on these parts, different frequencies, etc. So that's suspension mounts, engine mounts, isolators, roll restrictors, bushings, and those kinds of things. When we talk about rubber, it's not just the rubber itself. There's many ingredients that go into making rubber. We'll start in the center there with rubber. It's the base material, and that's, you know, allows the part to deform and then recover back to its original shape. Bob mentioned the oil, and certainly oil is really important in the processing of the rubber. It helps with the mixing of the rubber, and it controls the hardness of the final hardness of the rubber compound. Another key component is the fillers, and that's reinforcing the rubber, giving it its strength and improving its wear and giving it the physical properties, the rubber compound, the physical properties. Sulfur is also used. That's helping to cross-link the rubber to improve the stiffness, as well as the temperature range of operation. You might have heard of vulcanization, and that's what's happening with the sulfur and the accelerators. It's providing cross-links between the polymer chains, allowing the material to deform and come back to its original shape. If you think about just regular rubber that hasn't been vulcanized, if it gets too hot, it gets very sticky. If it gets too cold, it becomes a hard ball, or kind of glassy, I should say. And vulcanization broadens the temperature range of operation so that maybe it doesn't get sticky until a much higher temperature, and it doesn't get glassy until a much lower temperature. And then the other chemicals that are used in rubber formulations, the antioxidants, the anti-ozonants, really again are there to prevent degradation and keep the stability and durability of the material. And the other processing aids are also added into the rubber during the mixing process. This is a typical natural rubber part recipe. We kind of have a funny lingo in terms of how we measure out these materials. It's all in parts per 100 rubber. And so we start with a base of 100 parts of rubber, and everything is by mass from that point on relative to the natural rubber. So all rubber recipes, you start with your base rubber, you have some sort of filler, some sort of plasticizer, which would be the oil, kind of the other chemicals to help with processing or aging performance, and then the curatives. I just wanted to give you an idea of what a recipe looks like. When we look at future for sustainable rubber, we're really looking at bio-based oils, so a replacement of that petroleum oil with could be soybean oil, That's our preferred option here in North America, or it could be something like orange oil or some other bio-based oil. Looking at some different sources for elastomers, as well as renewable fillers. When we go through the process of trying to build upon or create a new recipe that contains new material, or modifying a recipe to contain new material, we really have to go through these 4 steps. We start with the materials development. So we look at the rubber recipe and we try to modify that recipe and in the laboratory to see how it will mix. From there we go and compound the rubber, go to the laboratory predictors. So we actually test it. Usually we do some instron testing, some dynamic mechanical analysis, etc., to really understand the physical and mechanical properties that can be attained with the new formulation. From there, there's a picture here of a tire tester and a tire flat track, but really, and it could be either a tire itself, it could be a part, an MTS machine for rubber part testing, to see how the actual component then performs, and then eventually we have to go to the vehicle evaluation. All new parts are tested on a vehicle for durability to make sure that we're going to maintain the performance of the vehicle itself. Okay, now we're going to get to the F-150 slat pad, the tip insert, which was our first application of soybean oil and natural rubber part. And again, this work is, we greatly appreciate the support of the United Soybean Board. Not sure this work would have happened as quickly as it did without their support. So the purpose of the slat pad. This is a slat pad. It's on the leaf spring in the back end of the bed of the truck. It's a part that prevents the 2 metal pieces from the flat pad as the vehicle is kind of bouncing over dirt roads or any potholes or anything like that, from the metals from hitting each other and creating a large kind of sound. And so you really want to minimize the metal contact. The key attributes that we're analyzing are the NVH performance, that's noise, vibrationist, and harshness performance, and the durability. It must be able to survive the life of the truck. And there's 4 natural rubber slat pads per vehicle. So that was our success. How did we get there? We did work in our laboratory with the formulation. We were replacing the naphthenic oil with the soybean oil. And when we did that, and we looked at our physical properties, we kind of had a shift in the physical properties when we fully replaced at 100% of the naphthenic with the degummed soybean oil. With work in the laboratory, we found a way to then, excuse me for a minute, there we go. We found a way to modify, we call it the cure package, that would be the level of the sulfur in the accelerators, to bring the mechanical properties back in line, or the physical properties back in line with the control formulation. So we found that, yes, 100% replacement of the petroleum oil is indeed possible. We tested it at 20, 50, and 100% replacement. The supplier, our supplier partner, Rossini, then took that formulation and tested it themselves, as well as then put it into their proprietary formulation. And they came up with an ideal replacement of 40% of the naphthenic oil with degummed soybean oil. And you can see that the physical properties met all of our specifications. So the parts were produced, placed on durability vehicles. After the vehicles ran through their paces, we found that the part was performing extremely well. So new drawings and part numbers were issued. All of this work with testing the vehicles and creating the new drawings, that goes on to other areas within the company. So there's many people that are involved in this process. And then eventually the parts were produced and released into production in February of this year. So there's many different engineering streams that are involved in the process of developing and implementing new materials. The benefits of the soybean oil tip insert, 40% reduction in petroleum oil. We had no compromise in performance, and we're using, in this case on the F-150, 2,700 pounds of soybean oil, but we anticipate, since this is the first part, we anticipate being able to now transfer this knowledge to many, many other parts. And as I mentioned previously in this presentation, we use about 6.6 pounds of natural rubber per vehicle. And so at 40%, if we replace 40% of the petroleum oil with soybean oil, we're up to about 400,000 pounds of soybean oil per year. So that's our goal. Another project, again, that is being sponsored by the United Soybean Board is looking at replacing the petroleum oil in the chlorinated polyethylene rubber that's used in the fuel hose. We've done some testing already and with our supplier. It has passed all of the initial testing. There are a few more tests to run to ensure that we are providing resistance to heat, ozone, and abrasion, and we anticipate that we'll be launching that in the very near future. So why are we interested in soybean oil? We certainly need to get away from aromatic oils. They were banned in Europe, and but in general we want to move away from petroleum oil as much as possible. In North America, the soybean oil is abundant and is cost effective for us, and from a green perspective, sequestration of carbon dioxide and a reduced global warming potential. Other materials that we're considering here at Ford for use in rubber, we have alternatives to Havea natural rubber. We're looking at Wyolie and TK dandelion rubber, recycled carbon black, recycled rubber, food waste as a filler. There's plenty of opportunities there, cellulose, and then bio-oils. So we're working in all of these areas currently here in our elastomers research at Ford. Regarding the natural rubber alternatives, I just wanted to make everyone here aware of kind of some of the new opportunities. We've been looking at Wyolie, which is a rubber that's extracted from the bark of a shrub that's grown in the desert Southwest, as well as TK dandelion, and that's rubber that's extracted from the root of the dandelion. That's a very specific kind of dandelion. It's not the kind of dandelion that's grown that grows in our backyards, but it's showing some really nice potential, and that would be grown in mild regions. So we really want to see if we can find a domestic source for some of the rubber. Most of the natural rubber currently, about 90%, is grown in Southeast Asia, and so we would like to have some opportunities to expand the capability of producing natural rubber here in North America and provide another crop alternative to our farmers. So we're partnered with the Ohio State University and the Ohio Agricultural Research and Development Center on these projects. And we're a founding member of PENRA, which is the Program of Excellence in Natural Rubber Alternatives. Goodyear is also involved in that program, and we're really working hard to see if we can not only, our testing indicates that the material looks good. Now it's a matter of making it economically viable. So I guess the final question here is, do sustainable materials sell cars? Not directly, I guess, would be the answer, but certainly it improves our brand image. It's protecting the business from future unknowns. We want to reduce our environmental impact, and I think that the next generation of customers are going to be even more aware of the need for the use of sustainable materials, and knowing that it's just kind of the right thing to do whenever possible. So with that, let me finish up with career opportunities here at Ford. We have many different areas here within Ford for engineers, marketing, you name it, purchasing people. So these are all of our different organizations within Ford. We have a website where you can look at all the different opportunities that might be available. That's careers.ford.com. You sign in as in the United States, and I'm a student, and I would check back regularly as that is updated as positions become available. And I think with that, I'm all done. love to hear some questions.
Okay, great, Janice. Thanks a lot for a great presentation. Before I turn it over to Karen to pose a few, Karen Edwards to pose a few questions, I'd like to go through a 3 questions we'd like to have everyone answer. On a scale of 1 to 5, with 5 being the best, how would you rate this webinar? We like to ask these questions so we can judge whether we want to do additional presentations like this in the future. Okay, I think we can move on to the next question. Did this webinar positively impact your opinion on the use of soy as a sustainable feedstock for bio-based products? Answer yes or no. And then we can go on to the final question. If you're a student, has today's webinar increased your interest in bio-based related research or career? Answer yes or no. Okay, with the time we have left, I'd like to turn this over to Karen Edwards and look at some of the questions that were sent in while the presentations were being made. Karen?
Yes, and just so everyone knows, if you want to type in your questions at the bottom of your screen, we'll be able to try to go through those. We've got some great questions already. Let's start with, does Ford or Goodyear have any plant tours where people can see your manufacturing facilities? Janice, I know the answer to that, so do you want to be the first to lead that response?
Sure, I can start with that. Here at Ford, we have here in Dearborn, Michigan, at our Dearborn truck plant, we do have tours. They're run through the Henry Ford, and they go through the final assembly process. But it's quite an informative tour to see how the vehicles are produced, as well as some of the history behind Ford. The Dearborn truck plant is one of our oldest facilities, and there's a lot to learn from that particular tour.
Bob?
Yeah, on the Goodyear side, at least here in Akron, just because it's an R&D facility, we don't have tours too often to the public. Obviously, any students that were to, receive an internship here, the opportunities are pretty vast. When you're brought on, often a plant assignment is part of an internship possibility.
Great, and one of the questions we can answer was, can you please share the presentation to the audience? And in fact, we have been recording this webinar, and we'll have it available after the fact. Let's move on to another question. Is oxidation and rubber cracking a problem with soy oil addition? Bob, do you want to start with that one?
In terms of cracking or oxidation, there's no appreciable difference between the rubber compounds containing soybean oil versus petroleum-based oil.
And one of the additional questions was, is it traditional soybean oil, or is it high oleic?
It is conventional soybean oil.
All right, Janice, do you want to take those 2 questions?
Sure. I agree with Bob that we don't see a difference in the oxidation or oxidative performance between a part containing petroleum oil versus soybean oil. So there's no degradation of performance there. And then as far as the parts that we've tested, or what I presented, they contained B-gum soybean oil, but we are looking and have some research that is also with the support of the United Soybean Board on the use of high oleic soybean oil in parts. And we're in the midst of that project right now, but it looks very promising.
Yes, Karen, I'd like to add real quick that Goodyear is also, we also have a separate project with the United Soybean Board looking at high oleic soybean oil in other applications.
Okay, great. And Janice, this is a question for you. Are the rubber soy vehicle parts compatible with biodiesel B100 or biodiesel blends? Am I correct that none of the parts that you were referencing in today's webinar are actually in contact with? Ford does have a wonderful history of supporting biodiesel and has even branded their vehicles, some of them, that they're B20 compatible. So, Janice, are any of those parts you were talking about today in contact with biodiesel where they would need to be compatible?
Currently, parts that we have tested have not been in contact with biodiesel, and certainly that's an area that we will be moving into in the near future to take a look at. I would anticipate there would be some compatibility, but I don't have any data on that right now. But you are correct. We are big supporters of biodiesel, particularly B20, but certainly, how can we utilize that particular material or fuel in the future, even in greater quantities, is a goal of ours.
Here's a technical question for you. Soybean oil's TG, how will it be affected during processing because there are double bonds?
I can start, but Bob may please jump in. We end up looking at the TG of the compound itself after processing. So both the petroleum oil and that we use in these compounds and the soybean oil have carbon-carbon double bonds. So they seem to be reacting similarly, and we just know that the compound.
I could jump in here.
Thanks.
We, in terms of the processing, we really didn't see that much of a difference, attributed to the unsaturation. In fact, we can't directly measure the glass transition temperature of the oil itself. We had to actually determine that through extrapolation, where we extended a polymer cement of known TG with varying levels of soybean oil and extrapolated it out to that low temperature. But in terms of overall processing, it's not that much of a difference, other than in general it's an overall better plasticizer than the naphthenic oil that we use.
This may be a little bit easier question. What is one piece of advice for a recent college graduate in engineering discipline that both of you would like to share?
My advice would be, particularly someone that's in the sciences, if you get an opportunity to get into a mature industry, really use your past experiences and the fact that you're coming in without any biases to your advantage, particularly in the areas of technology. Rubber and tires, it's a very mature field, but and there's a lot of, well, this is how it's always been done, or we did that before, that will never work. Sometimes when you come in, you look at things through a different lens without the past experiences that sometimes, really narrow our focus. So I would say that, if you're an engineer or a scientist coming in, to a new industry, don't be afraid. If you have a new idea or something like that, just throw it out there, because a lot of times it's that fresh look that can really lead to a potential big breakthrough.
I will echo what Bob has to say. I would say ask a lot of questions, and don't be afraid to present a new idea.
Well, and someone in our audience has recognized that both of you are good communicators, and they're asking for your recommendation on how to improve written communications in science.
The big key is to know your audience. You know, I have presentations on the soybean oil polymers that are, you know, ready for public consumption, super high level, and then I also have, you know, incredibly detailed technical reports, presentations, you know, cross-functional materials. It's the main key is just to really know your audience. Because normally when you're communicating your technology, you're trying to sell it, but you got to think about, okay, I'm selling it to this person, this group, this team. What do they want? And how does my idea or how does my product help them get what they want?
I actually had to laugh. You know, my husband's an editor, so we talk about this quite a bit. I would say outline, especially with written communication, outline what you want to say and make sure you incorporate background information into that and what are the key points that you want to make and build from there.
Sounds like great advice for all of us. And our final question is probably a good one to wrap up on. Can you tell me the percentage of soybean oil used in Goodyear tires and Ford vehicles? And Bob, if I'm correct, you have taught me that Goodyear has displaced 100% of the petroleum in the tread, which means 60% of the petroleum in the WeatherReady Assurance tires. Is that correct?
That is correct. Yeah, there's no petroleum oil in the tread compound. We removed it all. We replaced it 100% with soybean oil, but there is still petroleum-based oil in some of the other components of that tire. So the overall reduction in petroleum oil is 60%.
And Janet, how would you like to articulate a summary of how Ford uses soybean oil?
Yeah, I think our biggest usage has been in the soy-based foam to date. We'll continue to try to improve those levels, but I believe it was in my presentation we've replaced about 5 million pounds of petroleum oil annually with soybean oil.
Awesome. Mike, any final comments from you? I think we've coming to.
Yes, I'd just like to thank everyone for participating in the webinar this afternoon, and I'd especially like to thank Janice and Bob for making excellent presentations like they always do. I always learn a lot, and it's always exciting to have an opportunity to work and visit with companies like yours that really take something that our soybean farmers produce and really make something happen with it. So thank you very much, and again, thanks everyone else for being on the call today. And with that, I think that ends the webinar for today. So thank you.